Hello everyone, I'm Nikhil Muva, and for my space base I chose the location Europa. When picking a location, we had to consider four factors: the geosphere, the atmosphere, the hydrosphere, and the distance. The geosphere is includes all of the physical and solid parts of the um, of the body, which is which is essentially just the makeup of the body, um, the landforms, the physical features, and etc. So, and the atmosphere is the makeup and of the gases surrounding the body, but it is also the thickness and its ability to protect from other um, from interference, essentially. And the hydrosphere is the amount of water and location of water on this body. It does, however, include other liquids, as we see with Titan, and distance, as all three of these, or as all four of these bodies are moving through space, and the location does differ depending on what point in time, and thus we would have to calculate the average distance from Earth at any point. Starting off with Mars, the geosphere is generally rocky and iron-rich. It has many volcanoes and canyons. Titan is icy and rocky. It has cryovolcanism, which is volcanoes, but however they spit spew water instead of lava, which then cools as the body is below 0 degrees Celsius and creates volcano-like structures, and has dunes of hydrocarbon particles, such as sand dunes. Europa is also an icy surface. However, it has a subsurface ocean, and a very deep one at that. It also has some tectonic activity, meaning there's movement under the crust. And the asteroid belt, it is very mineral rich. It's a metallic and very rocky, has a lot of carbon, but however it doesn't have a very unified structure as it's a bunch of asteroids. The atmosphere of Mars is very thin. It's mainly made of carbon dioxide and has little nitrogen or argon. It does, however, have many dust storms. Titan has a lot of nitrogen. It's very thick, and it has a lot more pressure than Earth. Europa is very thin. It has high levels of oxygen, however. Asteroid belt has no atmosphere. However, some do have degrees of water vapor surrounding the asteroids. Mars, once again, its hydrosphere is generally has water in only the poles, with some frozen water underground. There is, however, evidence of lakes and rivers in the past. Titan has lakes and rivers of liquid ethane and methane, and it's believed to have some water. Europa has obviously this huge subsurface ocean, and is mainly made out of ice and has also some cryovolcanic activity. The asteroid belt has very little water, excluding the water vapor. However, some asteroids do have water at the core. Mars has the average distance of Mars is only about 224.5 million miles. Titan is at 1.4 billion miles, which is a lot farther. Europa is at 628 million miles, and asteroid belt, it is a range from 329 million miles to all the way up to 478 million miles. Some commonalities between them are the presence of valuable resources, as all have water. So all of them are believed to have water or some levels of water. And in Titan's case, liquid methane and ethane, but it is also believed to have some water. There are all extreme environments, very, very low temperatures generally, with thin or no atmosphere. Radiation is believed to is definitely a situation because of the thin atmosphere, and the extremity of obviously the asteroid belt is that it is very ununiform. It is not a single structure. They all have evidence of past or present activity, geological activity, meaning there was riverbeds in Mars, or there was rivers in Mars. There was activity there. Europa has the subsurface ocean activity, but also the tectonic activity. Titan has a dynamic atmosphere, obviously, because of how thick it is, and the asteroid belt is very harsh, as there's collisions all the time. They all have some potential for life, Mars being within the habitable zone, and showing evidence of rivers, lakes, and being very similar to Earth in the past. Europa, to a similar degree, that has water, salts, and its subsurface ocean, which would most likely result in some single-celled or microbial life. There's also energy. They all have energy sources, such as the sun, but there is a degree of volcanic sources from the core and the such. I chose Europa because of its water resources, its vast water resources. Water is essential for supporting life. It provides the hydrogens, and it does also mean that there is a high likelihood of salts, and which are also essential, and also a high likelihood of carbon, which is the case in Europa. It'll also help with other more technical things, such as fuel production and study of, and I think, transport, because of how thick the crust is. The astrobiology potential is that being distant from Earth, or more distant than some of its counterparts, is useful because of how we can more easily surveil our solar system, and the setup there does not require as much effort as other places. There's scientific opportunities, such as the unique features like cryovolcanism, which doesn't happen on Earth, obviously, as it's hard to find situations where it's below zero. The ice tectonics, the tectonic plates made of ice, and water vapor plumes, and it being an exploration gateway built on what we said before. It'll enable missions to Jovian moons, meaning Jupiter's moons, such as Ganymede and Callisto. This is my engineering design notebook and sources.